You let me know if I shall start, right?
Yes, you can start.
Okay, all right, sorry. Then, yeah, hello, good morning. Welcome to my presentation. Hello to Lyon. I'm sorry I cannot be there in person, but I'm looking forward, to be there next year. Today I'm going to talk about IoT at the edge, and that nothing is as stable as change, especially with edge or in IoT in general. So my name again is Kai Hackbarth. I'm business owner industrial / connected assets. So I deal with a lot of projects at the edge. Edge could mean factories, or the edge in the factories, or the cars, or other kind of edge environments. Right. Let me. Okay, so I give you a little bit of my background. So I started my journey in IoT in 2001. Back then, I joined a company called Prosys Software, not to compare with the French company Prosys. So they do OPC stuff. We back then focused on middleware for connected homes and remote management technology. So when I started, we were one of the few software vendors focusing on connected home. The term Internet of Things wasn't really born, and when it started to become or to be used was really just in the scientific research community, but it wasn't really a thing that we used. So we talked about connected homes, smart homes, connected vehicles, these sort of things. And as Prosys, we started to offer an open platform, a middleware for the edge. And that was scary for many of the customers we were talking to, especially if you think about car manufacturers. They were afraid of having software from external parties coming into the vehicle. What does it mean about liability, warranty? What if something breaks, and so on? So that wasn't really, something they were open to, I would say, at least not very easily. Open source back then wasn't really a thing, right? So there were a couple of open source activities, I guess, in around 2003 or so. The Eclipse Foundation started. So it was just not really something that was on the agenda of companies back then, right? And I remember very well, especially in the smart home area, that everybody was on the hunt for the killer application. We were always talking about what is this smart home killer application. And SMS was just, the prime example. They wanted something similar that scales like immediately. Obviously, there is still not such a thing as a killer application. I think it's a variety of things that really helps with adoption. Back then, investments were not made due to missing business models, right? So nobody really wanted to go take the risk and start with something very simple. And that also led to a couple of cancellations. I mean, cancellations in the sense that couple of companies decided, or they actually went with us through the whole development cycle. The product was basically ready to be launched, but they didn't do it. And this was just due to high risk again. Risk in the sense that when we ship the products, there are costs, right? And they didn't want to go this way. So in summary, I would say we were offering a solution for a problem that did not exist back in 20 years. And fun fact, I always used to be the youngest guy in the meeting room. At least it felt like it. So at Prosyst, Java and OSGi, I'll tell a little bit more about this, and the coming slide was at the core of our products. So OSGi is an industry alliance that was founded in 1999, and what they or what still exists, what we define is really a modular software architecture. Following the service-oriented architecture principles that allowed to provide a common software platform for distributed devices, also for to support multi-device vendors. We had a software framework what we call targeting all device classes, which is not exactly true. I mean, it was Java, so we were focusing on, let's call it, more heavy or with higher resources and so on, right? So it's a worldwide accepted standard, and Bosch IO is using it as part of the Bosch IoT Gateway software and the Bosch IoT Remote Manager today. And so these are the technical benefits of OSGi in IoT as of 20 years ago. You may wonder, this is old stuff, but again, what we think, what we expect today from a software platform, we did it already 20 years ago. This is sort of the key message I want to come across. So portability of applications was a big thing. Java enabled this. So as it is an interpreter language, and if you have like a pure Java application, you can just reuse it on different platforms without doing anything, basically, right? Then dynamic discovery of system discovery of service and APIs. So features and new features could just come in and go as needed, right? Same for devices. Modularization was a big thing. We wanted to have something that it's not a monolithical application in the end, that can evolve over time, that can be managed over time and maintained over time, which also led to a higher degree of code reuse. And lots of the shelf components that could be made available then to customers. And then also something that was a key aspect already 20 years ago is the fact that applications and services on the platform are remotely manageable. So we could deploy new features, we could monitor the environment, we could do remote diagnostic, lifecycle management, change configurations, and all this, right? 20 years ago. Obviously, there were a lot of concerns with respect to Java and OSGi, but still we made it to market adoption, I would call it. So 20 years ago, Java for embedded devices was not an easy sell. So that really meant you needed more resources. I mean, in terms of CPU, RAM, ROM. There were also costs for licenses. So that was something that was not very easy back then. So we were not thinking in like building ecosystems as we do it today, where things evolve over time, where features can be deployed over the lifetime of the device and so on. At least not so much. Java was considered to be slow, which wasn't really true. But if you use it the wrong way, obviously, it could have been like this. But that was like a perception thing, I would say. Then OSGi was also perceived as too complicated. Reason being that we forced developers to think more about the design of their applications before they start coding. And in many cases, developers just want to start developing and not think so much about the design of the application, right? And then there was an issue we had in, I think it was 2004, around 2004, where BMW in the 5 Series, there was an OSGi-based infotainment system that came from a competitor of Bosch. They had their own OSGi implementation, and I don't want to say they screwed it up, but in the end, the performance wasn't good enough. So things like startup time and so on, and that caused a delay of the launch of the 5 series. So that was a big thing that didn't help OSGi, unfortunately. And then the reality is that there was, and probably to a certain extent, there isn't really a standardized alternative to OSGi. And standards are crucial to build evolving ecosystems such as Deutsche Telekom, Kiwicom, that use OSGi in their routers, for example, for smart home purposes. OSGi, if you do it right, obviously helps significantly to reduce development maintenance costs, right? And as I said, we still made it, yeah. So I would say we had a good enough, or still have a good market, enough market adoption. It's being used in several millions of home gateways, home energy management systems, PLCs, large engine controllers, and so on. So really across many different domains. Also, Bosch is using it in different types of products for agriculture, for smart home, for industry, and so on. So why we still need the Edge for IoT, right? So there are a couple of things that a pure cloud-based solution, in my opinion, can simply not do, right? So especially when we talk about integration of non-IP devices, yeah, that's something, you need to have a gateway that sort of integrates these sort of devices. You want low reaction times, low latency. That's also something you cannot guarantee with a pure cloud-based solution. And in our case, at least, that's closest Bosch experience, I would say. We had to always sort of deal with a heterogeneous field of protocols. So there is not just one protocol that we use in our deployment. So there are many protocols, or maybe at least a couple of protocols, right? And then you want to have some local mechanisms, right? So, I mean, if there is no connection to the cloud, you want still to be able to have local notifications. You want to have some rule-based business logic, I would call it, yeah, and these sort of things, right? So, looking into where we are today in 2020, it's really all about platforms and ecosystems. There is a market study from a company called IoT Analytics. They just had an update of it this year, where they list about 620 plus IoT platforms, which, if you think about it, is just insane. But there are also many different kind of IoT platforms here, right? So they don't. I mean, this is a collection of things, right? So sometimes it's really edge centric, sometimes it's cloud centric, sometimes it's also about analytics and so on. Today we use IoT in many different domains. Energy, industrial IoT, smart home, healthcare, logistics. It's really almost everywhere, or it's coming everywhere, if you want, right? We have to deal with a wider range of devices. This could be simple temperature sensors, but also complex machines in a shop floor. And if you think about the complexity is increasing. And what I mean by this is really, if you think this end-to-end, smart home is part of smart energy or smart grid. If you want, smart grid is part of smart city, and there is not a single solution that can handle this complexity, right? So I mean, all the different players in this domain will have to collaborate on this. And the edge is still a crucial component for building IoT solutions, just as I mentioned before. Privacy and security obviously is still a major concern from a user point of view. And this is just to visualize this complexity, as I mentioned. So I like this slide because it really gives you a visual impression of the landscape IoT, right? So this is from 2018 from Matt Turk, who has done this, over the past years. As you can see, this is very complex in different industry, different kinds of areas, building blocks, if you want. And here you see basically the same landscape from 2016, which you see the difference, right? So I just want to point out how things are growing and how more complex they are becoming. And also, when we talk about IoT at the edge, the complexity of software is growing exponentially. So I have here an example of, let's say, the amount of source code that we have, for example, in a car. So this is the example Mercedes S-Class. So in 1995, we had just a couple of functionality like the anti-braking system and so on. So if you would print out the source code on A4 pages and pile it up with folders, it would be like 3 meters tall. And over time, the functionality in the car, has grown, right? So we have now infotainment system, we have navigation systems, and so on. And in 2020, with also functionalities about autonomous driving, level 2, level 3 maybe. If you would print out the source code here again, it would be as high as a Bosch Khalifa in Dubai, which is about 830 meters tall, right? And we expect this to be even taller in the coming years, right? So so again, just to give you an impression of the complexity that we need to deal with just at the edge, right? So IoT at the edge, 20 years of change. So this is just my view of some major things that have changed. My perception. The hype on IoT started around 2012, I would say, when big corporations started to invest big time in IoT. And Bosch, I would say, was one of the forerunners. They actually started already with Bosch Software Innovations back then in 2008. But again, so now other companies were coming into the game, like Amazon and so on, right? Then there was also a lot of venture capital investment in IoT startups, and you also saw a lot of initiatives, IoT innovations coming out of crowdfunding initiatives and so on, right? So there was really something starting to grow, I would say. Then there were over time a lot of IoT standards organizations that were working on different kinds of building blocks, I would call it, be it platforms, be it protocols. I still remember 20 years ago, we were proud to be, supporting UPnP or USB and so on, right? So and KNX and these kind of protocols. Today we deal with many more protocols. You can name it like Zigbee, Z-Wave. In the industrial domain, you need OPC-UA support. And so on, yeah. And what we currently see, there is some consolidation underway where organizations start to merge and so on. Also, what has changed that I think is crucial to take into account, that open source has become crucial to build developer ecosystems. So nobody wants closed systems anymore. We want to build ecosystems. We want external participation, I would call it, right? So in order to build these sort of ecosystems. And then what has happened, I would say, more in the recent 2-3 years maybe, that container technologies like Docker and so on moved from the cloud to the edge. And what we also see is that the amount of IoT devices is just growing exponentially, and you see also that the life cycle of especially consumer IoT devices is like getting shorter and shorter, right? So new versions of Alexa coming like every year and so on, right? And we also, as a customer, as a consumer, expect that we can receive continuous feature updates, and the same is true for industrial customers and so on. Hardware vendors invest in software. Companies like Bosch, we build our own IoT platform. GE has done the same, and so on, right? At the same time, you see also that what we perceive as software vendors develop now IoT hardware. So Google and Amazon are good examples here, right? So, and another thing that is sort of happening, I guess, is that the cloud is moving closer to the edge, right? So we have edge at the edge in factories, for example, we have the functionality that we are using in the cloud, basically closer to where the machines are. So this is just a snapshot, really, of new technologies and programming languages that are coming to the edge, or maybe already at the edge. So we have these container technologies like Docker, Kubernetes, and so on. We have now, we did Java, OSGi in the past, but now you can do many other things. So for analytics, you would, do it with Python. Go has become, a fashionable programming language. Node.js is great for building user interfaces and these sort of things, right? So this is sort of, changing a lot as well here, right? So, and also we, as at Bosch IO, are adapting to this. So we are also now working on a new Bosch IoT Edge software stack. And so this is also going to be container based, as you can see here. So we have here, I hope you can see my mouse, in the lower part, just above the devices. We have here containers for Bosch IoT Edge services, for Edge applications, and so on. So the IoT Edge services, this could be, for example, our Bosch IoT Gateway software, the Java OSGi stack that we don't want to just, discontinue the functionality we have. We can just, containerize it and still use it. So we keep developing this. And then we might have functionalities that might also come from third parties that do specific applications. That could be, analytics, could be machine learning, could be some specific business logic for specific purposes, right? And then we have what is new, an IoT Edge agent that is a native application, if you want, that can be cross-compiled for different types of environments. And these containers then basically can be managed through an MQTT API. So we can also add here new features, change configurations, basically the same story that I mentioned also in the case of our OSGi stack. And there might be also other containers for other purposes, as you can see here, that are sort of customer specific then, right? And then obviously there is, the cloud here, and here we basically have our Bosch IoT Hub, our Bosch IoT Sync services and other services in order to manage these environments. So like I mentioned before, rollouts can do software update. The IoT manager can manage the configurations and all these sort of things. And this again would happen through MQTT. So we sort of standardize this here in our way, I would say. And what we are trying to achieve with this is also especially, like I mentioned before, the Java OSGi stack, you could call it a disadvantage. We were targeting very specifically, more powerful devices like gateways, yeah, maybe even industrial edge nodes. But we also now want to move with this closer to the let's call it end devices, right? So where we have small microcontrollers or big microcontrollers, right? So in a small microcontroller, we want to be able, with the Bosch IoT Edge agent, for example, to deploy firmware updates. The big microcontroller, so we have here a couple of examples that are very Bosch specific, that are, they have resources that you can connect, for example, ECUs, you can connect with devices, so you may work with protocols, you may have some business logic behind it, right? So really, message here is really we want to be able to serve from low power, low capabilities types of devices to high power, high capabilities types of devices. All right. So what is our motivation? So we basically try to meet the market needs that we are seeing, right? So containers are sort of becoming a standard way of dealing or developing edge solutions. Open protocols are obviously very important, MQTT just being one of them. Lightweight native components, the edge stack, in order to be able to serve also these sort of small microcontrollers to run on a choice of platforms, enable the intelligence at the edge, or to enable the intelligence at the edge. And what we're trying to provide with this is really a fast integration, because existing applications, and I'm simplifying here, obviously, can be put into a container, can be, integrated into the, let's say, overall IoT solution. We want to reduce the complexity. We want this to be future proven, and obviously, in many cases, this shall lead also to reduced operation cost. So the Bosch IoT Edge stack is currently in development. The beta version is like almost ready, so we are expecting it to be available now any day. So could be tomorrow, could be Monday, but it's really just a matter of days now. And so if you are interested in getting access to it, please feel free to follow this URL here, developer Bosch IoT Suite service/edge, and you can then try it for free. So what is Bosch doing in IoT? Apart from Bosch I/O, we as, let's say, IoT platform vendor, Bosch really plans to become a leading IoT player. We want to make all our electronic products web IoT enabled, whatever you want to call it. We want to be able to offer new connected services for them, yeah, and also to expand this over the lifetime of the devices. And this obviously is, the intention here is also to generate additional sales as a result out of it, right? So, when we offer new services, this shall also lead to additional revenue. And how are we doing this? There are not many companies like Bosch that have so many capabilities like we are. Bosch, for example, is the world's largest MEMS manufacturer. So we produce, and I don't know if this is still true, 4 million a day. You find those in the iPhone, you find those in other smartphones, in many kinds of IoT devices, I would say, right? And the strategy is really that we bring sensors, software, and services, together. In this case, to enable, for example, something like a connected parking solution in the mobility sector, right? So all the different competences that we have available, to compile our IoT solutions out of it, and we call this the 3S of IoT: sensors, software, and services. And Bosch IO with the Bosch IoT suite is following here an approach based on open source and industry standards. So our IoT platform, especially on the cloud side of things, is like you could say almost fully open source. So there are different projects in the Eclipse IoT working group dealing with the different aspects, right? So these are also sort of, if you want, microservices. And we are also planning to open source the IoT Edge agent, for example. So there will be more open source activities. So we're really driving these projects. We are building an ecosystem through open source and industry standards. OSGi Alliance I mentioned already, and then we are also active in the Industrial Internet Consortium, where we basically build with partners test beds to validate also new concepts. This is just a map, about Bosch IoT Suite adoption map, that you have an impression in which domains we are delivering IoT solutions, or that our IoT platform enables, to say it like this. This is this is in many cases from Bosch divisions, but also from external companies like I mentioned Deutsche Telekom, but also others. We have about 10 million connected devices today, probably even more. This is always growing, obviously. And we say that we support 33,000 plus devices. This sounds like a lot. It is a lot. And this is also possible with the fact that certain protocols, like, for example, Z-Wave, you do not need to develop specific support for devices. So they basically just if you support this protocol, you support the corresponding devices. So this is how the large number of devices is also coming together. And then one thing that I'm very proud of, where I think IoT in general, and also, I mean, for me, I would say where we live up to our mission invented for life at Bosch, is the Vivalytic test device. That is a device that can test for COVID-19, but also other lung diseases. And so we just released this device in April. And so IoT enables here again provisioning of new functionalities. This could be like supporting a new printer. This could be other things. Obviously, we want to be able to provide also bug fixes, and we can also provision new test recipes. Test recipe means like we can do other, we can recognize other lung diseases, for example. So the test device already existed before COVID-19. With let's say the new test, the new test could just be deployed in the field, and be used by hospitals, doctors, practices, and so on, and that could be used then, right? And what is even greater, I think, is that so there's a lot of artificial intelligence that happened, or that has been used here. When we started, or when we launched this device, the test cycle was 2.5 hours, and with the help of artificial intelligence, they could improve this test cycle, and it's now 45 minutes. And also this can then be deployed to devices in the field, in the hospitals, and so on. So again, I'm very proud of this, and I think this really shows the value of IoT that we can deliver here, right? And so now I'm coming towards the end. One thing I would like to shortly advertise is we have an IoT Edge computing webinar on September 23 at 9 a.m. CEST, where we talk about market trends and cost optimization opportunities, and also go a little bit in more detail about our Edge, new IoT Edge stack. We do this in partnership with an analytics company from Germany called IoT Analytics. And if you're interested, please feel free to register. There is a URL. You can also scan this QR code here if you want. And yeah, with this, I would like to thank you for your attention. I hope I could live up to the abstract we provided, and I'm looking forward to questions if we still have time. I don't know, how are we doing this with the questions? I remember there was this URL. I'll have a look if there is anything. I don't see anything.